Section 13.6, this is the concentration that is used most frequently in chemistry. It's molarity. Molarity is defined as the number of moles of solute per liter of solution. So there's the equation right there. Molarity, and the abbreviation is a capital M, moles of solute per liters of solution. Just like with the percent by mass, it's the liters of solution, not the liters of solvent. It's the volume of the whole solution, and it has to be in liters, and the amount of solute has to be in moles. So making a solution with a specific molarity, you would, like in this example, a 1 molar that has nothing to do with teeth. That means moles per liter. So 1 mole per liter. So you would have to add 1 mole of sodium chloride. Well, you can't weigh that out on the balance. You'd have to convert it to grams and figure out how many grams that would be. You add that to a volumetric flask, which is designed to hold one specific volume, in this case a liter. So you add your solute, you add some water, just like about half the amount of water, and then you mix it and get it all to dissolve, and then you add enough of your water solvent to come up to the mark. These volumetric flasks have skinny necks, and they have a mark here. They're calibrated, and they're more accurate than using a graduated cylinder or a beaker or something else. Because the neck is really skinny, a small difference in volume will give you a larger difference in the height of the liquid. If you measured this in a beaker and you had 5 milliliters more, you wouldn't really notice any difference. But in this skinny neck, 5 milliliters looks like a lot. So that's why the neck is so skinny. Then you put the stopper on it, and you have to now invert it multiple times in order to get it to mix. So we need to learn how to calculate molarities, and then we'll learn how to do calculations with this, because like other concentrations, it can be used as a conversion factor. So calculate the molarity of a solution made by putting 55.8 grams of sodium nitrate into a beaker and diluting to 2.50 liters. On the mass percent problems, we do try to trick you sometimes by giving you the mass of the solvent and the mass of the solute and expecting you to put those together. On molarity problems, you will not find any trickery like that. So this 2.5 liters, that's the liters of solution. You add the solute, and then you dilute with the solvent to this volume. So that's your final volume. So we should first remind ourselves what molarity is. So molarity, capital M. Capital M's and lowercase m's, when you're written by hand, can kind of look the same, like just over here. Is that a capital M or a lowercase m? Lowercase m? No, it's a capital M. The students are always wrong because whatever they say, I do the opposite. Oops, I erased part of my M. So, if you're really being careful and making it all pointy and big, that's fine, but who has time for that? So, M, see, you don't know. So, a lot of times we underline it. An underlined M means that's a capital M. So capital M is molarity, and that is moles per liter. Moles per liter. And that's something you should memorize. It's really important. It's moles of solute per liter of solution. Well, what information are we given here? Are we given the moles of solute? No. Okay, well, are we given liters of solution? Yes, we are. Okay, so we could put that part in. So 2.50 liters. We need moles of solute. Well, we're given 55.8 grams of the solute, which is sodium nitrate. Converting between grams and moles should be old hat by now. Okay, like, driving home. You just know how to go there. You don't really have to think about it anymore. We can take this mass and we can convert to moles. We multiply by moles, divide by grams, and then we need to calculate a molar mass. Sodium is 22.99. Nitrogen is 14.01. And there are 3 oxygens. 16. I just forget to get my calculator out. 22.99 plus 14.01 plus 3 times 16, 85. It's like when you go to the grocery store and your bill comes out to be $60.00. And you're like, whoa, that's weird. 85. The calculator says 85. Does that only have 2 significant figures? No. Is it an exact number because it's a whole number? No. The calculator is being stupid. So this should have 0.00. So that's grams of sodium nitrate per mole of sodium nitrate. So this 85.00 goes in the denominator. And then we take 55.8 divided by 85, 0.656. It should have 3 sig figs, but there's some other digits. Let's carry along 1 extra 1. So that's the last significant figure. So it's that many moles of sodium nitrate. Some of these problems, we end up with these multiple steps, and you finish calculating something like that, and you feel this sense of completion, and then you're like, wait a minute, what was I doing? That's not the answer yet, right? So if you get lost, write a map out. Tell yourself, write it down what you're going to do. I need to calculate this, and then I need to put these in here so that you don't come to this point and go, what do I do now? This goes in the numerator. That's the moles of solute. 6565. Isn't that a cool number? So we take 0.6565 divided by 2.5 and get another cool number, 0.2626. But how many sig figs should that have? 3. So we'll round that, and we'll call it 0.263. The units are moles per liter. You can also use the capital M abbreviation, 0.263 capital M. So either of those are acceptable answers. Any questions? So molarity, being moles per liter, is useful as a conversion factor to convert between moles and liters. Because we have that equation, the molarity equals moles of solute divided by liters of solution, you can also solve these problems using algebra. Okay? And if you prefer that method, you go right ahead and use it. But I find that most students don't do so well with that. And so whenever we can use dimensional analysis, I think it's better to use dimensional analysis. So that's what I'm going to show you. But if you want to do it using algebra, you go right ahead. So here's another question. Determine how many grams of sucrose are contained in 1.95 liters of 0.781 molar sucrose solution. Now, it's probably not immediately obvious what we should do here. So let's take the numbers and write them down.